Okay, here we go. We're going to differentiate this question from the January 2006 paper. So the very first thing I'm going to do is I'm going to convert it into a product, so I can use the product rule. So I've got cos of 2x cubed multiplied by 3x to the power of minus 1, and just make that simpler for me to deal with, I'm just going to rewrite it, this bit here, as 1/3, that's the 3 to the minus 1 times x to the minus 1. And now I've got a product, so I've got my u and v. So let's start with the u. U is going to be the cos of 2x cubed, which makes du by dx equal to. So first of all I differentiate what's in there, so I get 6x squared, and then I multiply that by the differential of cos, which is minus sine 2x to the power of 3. And just tidy that up, so I've got minus 6x squared sine 2x cubed. And now my v. V is going to be the other term, which is 1/3 x to the minus 1, which means dv by dx is equal to minus 1/3 x to the minus 2. And now I'm going to substitute into the product rule. Dy by dx is u times dv by dx plus v times du by dx. And starting with the u, I've got cos of 2x cubed times dv, so that's minus 1/3 pardon me, x to the minus 2, plus v, which is 1/3 of x to the minus 1, times du, which is minus 6x squared sine of 2x cubed. Right, so this term is going to be negative, and it's going to be negative 1 over 3x squared cos of 2x cubed. This term is also going to be negative because of the minus here. 6 and a third is going to cancel to minus 2. X to the minus 1 is going to cancel one of those, so it's minus 2x sine 2x cubed. Okay, could leave it there, which is what I'm going to do. So that's my solution. And now we're going to compare it with what the mark scheme says. So this is what the mark scheme says here. Deal with that one later. So let's see if it's equivalent. So what we've got here, we've got a minus 3, and that's over 3x to the minus 2, so 3x squared. So the minus takes it down. Notice it's applying to the whole of the brackets, times cos 2x cubed. And then we've got minus 6x squared, and then over 3x, that's that minus 1 taken care of, times sine of 2x cubed. Right, well, we can see instantly we've got the minuses in the right place, and you can see we've got the sine correct, and we've got the cosine all fine there. So the question is, do these things match up? Well, yes, I think they do. Let's just see if we can demonstrate that. So here we've got 3x squared on the bottom, so this term here is minus 3 over 9x squared, because 3 times 3 is 9. That and that cancel to give you 1 over 3x squared, which is what we've got there, so that's fine. And then over here we've got 6 divided by 3, which of course is the 2, and x squared divided by x, which of course is the x. So this is correct. Now, what about Anna's solution? So this is what Anna emailed me. I'm going to try and match that up now. Okay, so we've got here, if I'm correct, a minus 6x squared sine of 2x to the power 3 times, now this is ambiguous, this is what she's written here, but that really should be in brackets, because otherwise the 3 will not be on the bottom of a fraction. So at the moment I'm fairly sure it's correct, but I'm going to assume charitably that's what you meant, Anna. So that's our first term there. So what we've got there, we've got a minus 6x squared divided by 3x, which is those two bits, and then the sign. And you can see that and that are going to leave us with 2, and then that and that cancel there. So that's the second term, so that's all fine. So I'm just going to stick those brackets in there, just because without those it's technically speaking wrong. And now the second term here, so we've got a minus 3x to the minus 2. Now again, a bit ambiguous here. What you really needed here was brackets there, because otherwise 3 is not on the bottom, which of course is important. Notice they put brackets in the exam solution answers. So in the cos 2x to the power of 3. So I think it's fair to say that overall lots of correct stuff, but a bit of misconception here potentially, depending on whether you meant the minus 1 to be applying to the 3 or not. Just to take you back up here, the minus 1 here definitely applies to the 3, which is why the 3 turns into a third in terms of it being a constant. Hope that was helpful.